Today we're going to talk about test pilots. A little bit of the schooling, what it goes into, how you make a test pilot, what they do, and a story or two about things that happened to me while I was doing the test pilot gig.
Yeah, it was very interesting to me. I appreciate all the information.
All right, looking forward to it.
Thanks, guys.
Hello, everybody. Welcome back to Mish Men. It is now the week after New Year's.
It is.
So I hope you enjoyed your New Year's celebration and you've enjoyed that first week back to work after Christmas and New Year's. That's everyone's favorite week to be back at work.
And hopefully you're hitting your New Year's resolutions already.
That's right. Yeah, giving to charity and going to the gym. So I'm here. I'm Adam Mauser and my partner in crime, Dusty Labar.
Hi, everybody. I'm Dustin Labar.
That's right. Good to have you back. It's been a week since we met, so I hope your New Year's went well.
It went really good. I'm already 100% done with all my resolutions.
That's good.
So I've already learned to play the guitar.
That's right.
And my other thing that I was going to do now that's escaping me, but I did it.
Why don't you play Folsom Prison Blues and I'll sing it right now?
Actually, I would. The guitar's over there. It'd be bad for things, but maybe Abby can put a cover of me playing it.
That's right.
And then it'll sound just like I would do it.
Yeah.
Okay. Great.
So this week, I hope you enjoyed last week's episode. I enjoyed talking about New Year's resolutions and our chit-chat afterwards. It was really interesting to me. But this week, I'm going to talk a little bit about my life as a test pilot. So I was just telling Dusty beforehand, I really don't identify as like what I do at work. That's not my identity. I prefer my identity to be a husband, a father, just Adam. Mm-hmm. And I prefer that. But I had what most folks would consider, and myself included, a cool job because it was a cool job I wanted to do before I did it.
Yeah.
And then while I was doing it, I was like, man, I can't believe they are paying me to do this. Yeah. This is just the best. It was much more in depth than what I thought it was going to be, but I loved it still. It was just awesome.
Mm-hmm. I'm excited to hear about it.
So we talked a little bit about this. I was a guest on the RFTB podcast.
One of the first times, right?
It was the first time.
The first time.
Yeah, because you guys were just kind of going through the bio and like, hey, you asked a bunch of questions and it was fun. But just talk a little bit more about that and just have a conversation about what a test pilot does. So a test pilot takes an aircraft and before operational people, and it's either before civilians in their general aviation aircraft or airlines or whatever. A test pilot, if it's a company test pilot like Boeing or Sikorsky or Bell or Embraer or whatever, Airbus, that aircraft goes through design and development phase. Mm-hmm. And so a test pilot works during the development of that aircraft and provides a lot of input into it. There's a lot of simulation and that sort of thing, and then flies for years on that flight to build a profile for that aircraft so it can prove out what it's supposed to be.
Yeah.
So that it's safe when regular pilots get in.
Yeah, I got you.
So that's what a test pilot does. That's his purpose in life, is to define the aircraft, its safety margins, and also its use. Because he will observe certain things and they turn into like notes, cautions, and warnings and stuff like that.
I'm going to have so many questions. I'm sorry.
Yeah, fire away.
Okay, so the end is test pilot, the cool thing. That's the cool thing.
Yeah.
Like, that's a cool job.
Yeah, I think so.
I think so too. That's what I'm saying. I'm saying that is a cool thing. What is in the briefest way you can do it, the path to get to that? Because like day one, like signing up for the military, day one, basic training to actually getting to be a test pilot.
So I'll describe it from the Army and a little bit from the Navy perspective, because the Army sends their test pilots to Naval Test Pilot School.
Okay.
And we have a joint cooperative agreement with them. And more about that in a minute. So you have to have a certain education pedigree.
Okay.
Largely engineering, hard sciences for sure. And if you've had certain classes and you didn't have a hard engineering degree or whatever, then they can...
Before the military or while you're in the military?
It depends. I mean, some guys do it while they're in the military at night school. Some do it well before.
Okay.
So that kind of engineering background, and the best engineers that end up being pilots may not be really good test pilots. They might not make it through test pilot school. But if you have an engineering mind, and I would call it, I'm going to borrow a term from Johnny O'Connor. He was one of the instructors. He was the chief of the academics at test pilot school, at the Naval Test Pilot School. The way he described it is farmer engineering.
Okay.
So basically, you're kind of inquisitive about the way things work, what makes them tick, what makes a good, thing that you use as a farmer. Mm-hmm. That guy can be a great test pilot.
Yeah.
Because you're always asking why. Okay, so this thing does this. Can we make it better?
Yeah, I gotcha.
Because even further back, like operational pilots, when you're flying your aircraft, you love that aircraft. Mm-hmm. Like that's your home. You're ultra standardized in the use of the aircraft. So there's many ways you can fly an aircraft, but then you standardize, because if I fly with this crew or that crew, the crews are always mixed up. Mm-hmm. I want to do the same things the way the guys did, so the crew chiefs aren't surprised, the co-pilot's not surprised when I'm doing whatever it is I'm doing to fly the aircraft. So you're standardized to the point where you're consistent, mm-hmm. and you avoid those. You operate the aircraft in this, this envelope. I'm holding my hands about 6 inches apart. There's this other area that, it's safe enough, but it might not be wise. And then there's these areas out here of like, you shouldn't be doing that. Yeah. So they want you standardized to where if you do need to broach that margin, very temporarily, because someone's shooting at you, then you can operate the aircraft safely.
Yeah, I gotcha. But so you were in the Army.
Yeah.
And then you had some path that led you to, like, is there a direct path? Like, you walked in knowing that you wanted to go that route? Or
I didn't even know about it in flight school.
You didn't?
I didn't know about the test pilot field at all.
Okay. So you went into it, like, there's no differentiation between a test pilot and like what is the difference? It'd be like a combat pilot. I don't know what are the.
So there's operational pilots, and then there's test pilots.
Operational pilots would be like guys that are on cargo planes or fighter pilots or all that kind of stuff.
Just doing whatever the mission of that aircraft was designed to do. They're just executing whatever that mission is. A test pilot helps define that aircraft if it's suitable for that mission.
So you go into pilot or flight school, and then those are the two branches you could go out.
And I didn't even know that there was this whole test pilot field.
So you walked in there thinking that you were going to be on the operational side, essentially.
I was operational.
You were already operational.
I was operational, and then you fly a number of years, get a certain amount of experience. You have the education background, and then you apply.
Before you went to flight school?
Oh, okay. I'm sorry.
I'm a little confused. So you had to go into flight school to fly.
Yes.
And then you were operational.
And I was operational for years.
some time. Gotcha. I understand. Okay. You have to treat me like I'm ignorant about it, because I am. I don't know exactly how it works.
So the system produces, like, they select pilots, candidates to go to flight school, and then you get to flight school, and then you go fly your aircraft. And most, 99%, greater than 99% of the pilots, they fly their whole career doing operational stuff.
Okay. And you were able to go a different route after you did some operational work.
Right.
Then you were able to go into the test pilot field.
Right.
Gotcha. So you didn't go, I guess, I didn't know this. You didn't go right from flight school to being a test pilot. You did some years of operational flight, and then you went over to be a test pilot.
You wouldn't be a good test pilot without that experience.
That makes total sense now that I'm thinking about it, because you have some real world experience and know what it should do. Gotcha.
Right. And plus you're comfortable. You're comfortable. Flying is more than just like wiggling sticks. There's the execution of a mission. There are the handling of the aircraft. It'd be like if you wanted to be a race car driver at Indy 500, like, they wouldn't pick a guy that got his driver's license that day to drive their Indy car.
That's makes a ton of sense.
Yeah.
When you were operational, what did you fly most? Or did you fly only one thing, or did you fly multiple?
Just flew one thing, Blackhawks.
Blackhawk?
Yep.
Okay.
Alpha Lima Black. So Alpha Lima is so Blackhawk UH-60, and then there are series, like the Alpha model was the first iteration of the Blackhawk, and then they improved a little bit, and then the Lima model came along, the L model. And then while it was in test pilot school, the M model was coming out, or was finishing up its development.
So there's another test pilot school specifically? So there's you were operational, then you went into another school to be a test pilot.
Yeah.
Where you learn
how to be a test pilot.
How to be a test pilot
Yeah.
specifically, because you're testing stuff that nobody's flown yet, really, essentially.
Right.
Yeah.
So good question. That's a nice segue to test pilot school itself. So what they do is they select the different services have different ways of doing it. There's only 2 U.S. test pilot schools for military.
Okay.
Naval Test Pilot School, the one I went to, and U.S. Air Force Test Pilot School.
Okay.
And they started right after World War II. I think the first class for the Naval Test Pilot School is 1948.
Mm-hmm.
And so they take an experienced pilot, someone with engineering background, engineering minded, and they mold them into a test pilot.
Okay.
48-week course. So it's essentially a year.
Yeah.
You have some pre-training before it starts that you're associated with the school, but you don't actually start till that's over.
Mm-hmm.
So for the Navy, you do swim tests and all that sort of thing, ejection seat training, all that sort of thing, and then you start the school and you get qualified in an aircraft that you might not have been qualified in. So when I went through TPS, I'll just shorten it to TPS, Test Pilot School. There are 3 curricula. At Naval Test Pilot School, there's rotary wing curriculum,
Mm-hmm.
there is fixed wing curriculum, and then the engineering curriculum. And so the engineering curriculum is made up of NFOs and just straight engineers that don't even fly anything.
Mm-hmm.
You can have some engineers in the other 2, but that one class is made up of 3 different segments.
Mm-hmm.
And they have they share a lot of the same classes, but they have individualized classes.
Sure.
So like the rotary wing curriculum covered fixed wing and rotary wing stuff because the Army has aircraft up there for the school to do that because we fly fixed and rotary wing here. So they have C-12s or King Air aircraft, dual engine prop rotor or props, and like a little tiny airline cabin area. Mm-hmm. And then they have Blackhawks. They have OH-58 Alpha Charlies. OH-58 is a small scout helicopter, like a Bell 206, if you remember what that looks like. And we also had, at the time, they got rid of them, H-6s, and that's like the helicopter on Magnum PI.
Oh, yeah.
Kind of egg-shaped.
Yep, I know what you're talking about.
One of the most fun aircraft to fly ever because it's unaugmented. It's no power steering, if you will. Mm-hmm. And it's like it's so small and agile. You feel like you strap it on.
Oh, I got
it becomes like an extension of you.
Yeah, I got you.
And you fly doors off most of the time, and it's just fun.
Yeah, you got your sleeves rolled up on your suit jacket.
Yeah,
yeah,
and sunglasses, of
course.
course.
Of course, yeah.
And my members only jacket.
Obviously, well, you couldn't fly without that. It's very important. Yeah.
So Test Pilot School is out of those 3 curriculum. They have you have academics. The joke up there is 50% of your time is flying, 50% of your time is academics, and 50% of your time is report writing.
Okay.
Because you're just busy, constantly busy. It is the hardest thing I've ever done professionally, ever, not even close to a second.
So report writing for a test pilot. So you fly in something that you're testing.
Yeah.
And something doesn't work. You have to write a lengthy report. Is that kind of or a report of your flight?
So they break it down into bite-sized chunks. So the first half of the course is performance for the rotary wing. It's performance. And that is where you learn how to collect the data and build a math model for the performance of the aircraft. So how much fuel it consumes, how much power it takes to consume it. And you can build it so you can build performance charts that the operator can use.
I understand.
So the second half of the course is stability and control. So lateral directional stability, because those 2 are coupled together, directional and then lateral. And when I roll, they're tied together because the gravity's down here is fighting against me. If I roll, I'm going to turn also. Yeah, so they're coupled. And then longitudinal stability. They've changed it to statics and dynamics, but the point is that is like the real test pilot stuff, and they save that for afterwards. So what you do is on those exercises, or what I would do when I was really doing test work, you have, okay, we're doing performance testing of the MH-60M Special Operations Black Hawk. And our altitude, we're going to fly these altitudes today, density altitudes, and you're going to collect data. You don't have a whole lot of test pilot-y input into that. You're just collecting data. You got to be a really good flyer, plus or minus half a knot on a sensitive airspeed indicator, no buffers or billows or anything like that, and maintain an altitude within, like 10 or 50 feet. But then later on, when you get to the real test pilot stuff, and this is back to your question, you are flying specific engineering maneuvers to specific parameters, and then you are collecting all these data. And then from those data, then you start applying these mission maneuvers that are similar to what you did when you were an operational guy, but in this other aircraft that you might not have flown before.
Right.
And then you are now characterizing that in engineering terms. So you collect all these data. You have the engineering background to look at the data you collected and make plots and graphs and that sort of thing. And then you say, okay, if I were doing this mission, let's say flying at night under goggles, we're in NVGs, so I have a limited field of view, right? And I have a sling load, and I'm flying multi-ship, so formation flight, and I have to land on a pinnacle. This could be really hard because the lateral directional stability of that aircraft is negative. It just doesn't return back to normal easily. I have to fight it back. And so the way you can characterize that is stick position indications, because you have those indications because everything's instrumented. And what you do is describe from the data that you have. It tells you a story that now you have to convey in words to a decision maker who is not an engineer, might not even be a pilot.
Gotcha.
And you describe that in terms that make it relatable. That's like the so what of it.
Does that person that's reading the report have to decide whether it's worth trying to fix what you're describing, or if it's a normal?
It depends on when it is. So if you are in the middle of the development phase, you try to identify those things that are going to be a problem. You can kind of look at the shape of the aircraft and the design of the aircraft and say, you know what, it's going to have troubles in this regime, so we need to make sure we do a lot of test points in that to exploit that and determine and collect enough data to make sure that, one, it's safe, and two, if it is safe, but when does it become unsafe? Yeah. And so that person that reads that report, that decision maker, a lot of them are pilots already, but they may not be engineering minded. So what you have to do is explain it like, this is a big deal.
Yeah.
And very rarely, by the time it gets to the test pilot phase, very rarely is it this huge problem that, like, oh my gosh, we got to start over.
Yeah.
But during the development phase, you're trying to highlight a red flag, like, hey, this might need some attention. And then the manufacturer is working with you to like, okay, well, if we put if we put some sort of damper on this system, would that help out? Well, let's do some testing, bench testing first, and then let's see if it works.
Have you ever had a major issue with a craft that you're testing?
Yes.
Yes.
So I talked a little bit about this on my my interview with you guys on RFTB several years ago. There have been episodes where it was like, "Ooh, man, that was close."
Yeah.
But this one was like the most notable. So I was testing at the time. The Army was going to buy these fly-by-wire versions of the Black Hawk. So a fly-by-wire version of the Black Hawk, like the traditional Black Hawk, is I am moving these mechanical systems, like the stick that you have. You're flying the stick, and you have the other stick in your hand, the collective and the cyclic. I'm moving this around. I got my pedals for directional control. Those are all connected, like your car, to push-pull tubes. And they're moving stuff, and they enter into hydraulics, and that helps out. And the hydraulics helps keep things nice and stable because there's a little computer that helps you keep stable. And everything's connected, and it makes sense. I know how far I am forward because I feel the stick that far forward, and that's as far as I can go. Well, this fly-by-wire Black Hawk was all electronic. So the sticks aren't connected to push-pull tubes, anything mechanical whatsoever. They just went down to little tiny computers.
Yeah, and the computers you move the stick, and the computers tell the rest of the stuff what's going on.
That's right.
Yeah.
And it had similar hydraulics up top that moved the moved components that changed the rotor pitch to control the aircraft for the tail and the main rotor. But I was basically a voting member because there's 3 flight control computers. They're all split in half, so it was basically 6 flight control computers. They had a voting mechanism, but it was all connected by...
Are you saying voting mechanism, like you make a decision to do something in the craft, and then there's 2 other computers that are also making a decision?
What I'm saying is we'll table the answer to that question in a second. So the voting is out of those 3 computers.
Yeah.
Again, they're split down the middle. We'll just call them 3 for now. If 2 of the computers say, no, we need to do this, that third computer that might have been extraneous had a different answer than those 2, he gets voted off by the other 2.
Yeah, I gotcha.
So that voting happens through software.
Yeah.
Now, when I'm moving the sticks around in this thing, I'm still just making inputs that go into those 3 computers.
Yeah, I gotcha.
And it does its whole software. If you're familiar with control theory, the listener, it's going through its iterations and it's saying, well, the pilot commanded this, so we need to give him that. But still just a voting member. And the example, when you ask the question about, and this will answer your question, anything that happened that was unusual. So we were flying a test point. It was me and a Sikorsky guy. So we were paired up with Sikorsky. And I was still in the Army then. So we were to fly this point where I think we were doing beep trim. So beep trim is kind of like resetting the null point of where the stick is.
Okay.
And I beep over into this turn, like a 60-degree turn, and we're going to monitor how the flight control computer is maintained because we're hands off, just beeping over how well it maintained airspeed in that 60-degree turn. So a 60-degree bank is pretty steep.
Yeah.
And it's trying to maintain altitude with the other levers. And it wasn't doing a very good job, so we knocked it off. So I think it was, Bill was flying. So I was flying the clipboard that day. He rolls back level, but then he's got the stick like it should be here to maintain wings level and maintain airspeed and altitude.
Yeah, basically like neutral.
Yeah, right in the middle. But he's like back here, and I'm like, hey, what are you doing? He goes, I'm trying to maintain altitude. And then in the meantime, all these flights are telemetered. So engineers, there's like 8 or 10 engineers in this telemetry room, and they're monitoring their monitors. But there's one guy that talks to you, and it was the flight controls software guy. He's like, hey, what are you guys doing up there? And that's not a good thing to hear.
Yeah. Something's wrong.
Yeah. And we're like, we're trying to maintain altitude because I was talking since Bill was flying. So we talked about it, and what we had to do was push this button that turned all the outer loop modes, which give you, it does all the processing that the computer's doing. And now you're going down to very little processing, just basic stick to what the rotor head is doing.
Yeah, you're telling it now. Now you're telling it what to do.
Yeah, we're just telling it, like, turn off all your magic, all the stuff that makes us fly better.
Let me take this.
And we're going to take this. Now, keep in mind, though, there's no push-pull tubes.
Yeah.
It's just still the computers.
It still runs through a computer.
And it's doing something that we did not expect at all.
Yeah.
Bill and I did not see this coming at all.
So obviously he's thinking that he should keep level with it here in front of him. And, in a normal or a regular helicopter, pulling it back like this would do some other kind of action.
We should be pitching up that far back. But
he's got it there. Instead of going up, you're just staying level.
We're staying wings level straight.
Yep.
So now, like, we agreed, like, okay, what we got to do is go into degraded direct mode. So I got to push this button. And we could have, in hindsight, we could have done a couple of different things.
Yeah.
But at the time, that seemed like the best solution. Now, all's well that ends well. I'm still here. But that was the first time that, like, I'd flown, a couple of 100 hours in this machine, this very aircraft, because there's only one of them that was, like, configured like this. The other one was just like it wasn't as instrumented. We weren't doing anything fancy in that. And I'm getting ready to push this button, and I was like, man, there's nothing between me and that rotor head. And the rotor head is that's giving you life, right? If that thing quits working the way it's supposed to, then we're going to crash and die, and it's going to be ugly because you can't control it.
Yeah.
And it's just wires and software. That's it. wires and software with some hydraulics in there in between. But that's the hydraulics is just doing what the computer tells it to do. So I'm getting ready to push the button, and that's the first time that ever occurred to me that there's not a whole lot of stuff, and we had never done that in the air. We had only changed into that direct mode, cutting off all the outer loop magic, if you will. We had done it on the ground, but we had never done it in the air because it was too high risk.
Like in simulation, they have a simulator for it, or
we had a simulator, but that was the first time we did it in the air, actual aircraft.
Yeah.
And it was kind of scary because what we should have done beforehand is like, let's try it at a hover in a benign condition. Let's try it in forward flight to see, because that was one of our emergency procedures. Like if this happens, go to direct mode and return to base. So I'm getting ready to push the button. Those thoughts are going through my mind. It's like a 2-second deal, but the whole time I was like, man, I hope this works.
Yeah.
I pushed the button, and we had a little jolt there where now the computers woke up like, oh, he's commanding this now.
Yeah.
They don't know any different. And we flew back home, and we did like a quick hot wash of, okay, here's what happened.
Yeah.
Was it supposed to happen? So we get the engineering team up from Sikorsky, the chief engineer, and the software, the flight control software engineer, and describe what happened. And all's well that ends well. Bill and I collaborated along with the lead flight controls engineer down at West Palm Beach, a guy named Dave. We collaborated together and wrote a report or a paper on the design, what was supposed to happen, what did happen, and then what we learned. Like what's some learning that you can get. And we presented it at a forum called the Society of Experimental Test Pilots out in Anaheim. It's an international symposium. It was really an honor to be able to do that.
Yeah, I bet so. That's cool.
But it was just an interesting time.
This may be a stupid question.
Nah.
So operational pilots, test pilots, Navy, Air Force, Army. What do you think the percentage is that go into like commercial flight of some sort? So like whether it's, flying for a commercial airline, or I know that there's like, there's commercial helicopters that you can fly or because that's obviously like it's something that you've done as a job, and you can go into the private sector and do something like that. Obviously you did not do that. What are the benefits of doing it, and how many people do you think do it?
A decent amount go to the airlines and fly, whether they're test pilots or operational pilots.
Yeah, just people that fly for the military.
Yeah.
Go into the private sector.
Most of your airline pilots are former military of some aspect. Most, just because they get a lot of experience flying.
Yeah.
And they know all about standardization. And they're very committed to it.
Yeah.
They see the value in it. A small portion of the test pilot community leave the test pilot world and the acquisition world at large. So the test pilots become acquisition people.
Like getting new or planes or helicopters.
Right. They acquire. Yeah. So the Army has a whole cadre of people. It's huge. And they get new equipment, and they make sure that equipment they shepherd it through the process from this OEM and on it goes. So,
gotcha.
So a lot of test pilots will go into program management or the acquisition community. That's what I did ultimately. After about, 13 years as a test pilot, and then went into acquisition.
Okay.
And then a very small subset leave the test pilot community and go to something like the airlines.
Okay.
To be just airline pilots.
Yeah.
Why that is, I don't know. Maybe it's interesting because it comes to the point like where once you've seen this side of aviation, whether it's civil aviation, and you're like an FAA test pilot. I've got a couple buddies that fly for the FAA, and they do the same thing that I did, but they do it for the FAA.
Like commercial planes?
Yeah, they are commercial helicopters and commercial planes. They're FAA test pilots that confirm what the manufacturer said is accurate.
Gotcha.
Before they get their certificate that says, okay, you can go fly this thing.
Gotcha.
Airline, you can buy it and use it. So a lot of the former test pilots for the military go to the airlines or the OEMs actually for the airlines like Boeing, Airbus, and then they go.
OEM is
original equipment manufacturer, so a manufacturer of an aircraft.
Gotcha.
So they will go and they will be test pilots for them. One of my classmates from TPS, Steve, I forget his last name. He was actually working. He was a pilot in the Navy, then got out of the Navy and then worked as an engineer for the Navy, and then went to test pilot school. Did a couple years, and then he left the Navy as a civilian employee and worked for like GE engines, and he did test pilot work for them. Because those skills translate easily to other things.
Yeah.
Because what a good test pilot will do is take data. And it doesn't matter what it is. It could be driving your car. They take the data and they say, okay, what does that data mean? Because the numbers don't speak for themselves, in spite of what the popular convention says. Numbers speak to themselves only when it's commented on by somebody with some kind of knowledge, because they determine, okay, well, these data are inaccurate. They're not qualitatively, they're no good. So not all numbers are good numbers. So they speak to the quality of the data, and then they say, okay, out of these data that we know are quality data, this could be a problem in the future when the airline pilot is flying in a degraded visual environment, and they got to land. This nose wheel could do this little flutter thing when they're trying to land, and it could be uncomfortable to the passengers, or it could be difficult to control on a wet runway, whatever. So those kind of skills translate. So very few just leave the test pilot community and go just fly like commercial. Just because it's once you see that side of it, it's just really interesting. There are some that they might make it through the school, but they're not good test pilots.
Gotcha.
And so, there's a hierarchy to there's a pecking order to everything. So there's like, it's good riddance. That guy's no good.
Did you ever have a desire to try to go to do something commercial, like commercial flight, or?
When I was a kid, and I thought about it while I was still in the Army before test pilot school. I had a number of friends that did it, and I'd say 90% of those guys, after a while, they're like, the airport life it's just horrible.
I could easily look it up, but I never have, and I've always wondered, like, I'm sure that commercial airline pilots make good money because there's not a lot of them.
Once you get to a certain stage, you make ridiculous money.
Crazy money?
Oh, yeah.
Yeah.
And for the amount of hours you work, it's
because some of these guys will do like I'll use an example, not saying these guys were test pilots, but like Allegiant, that flying from Nashville to where I'm from, Pennsylvania, they do like 3 flights. It's the same pilot.
Yep.
It's an hour flight. Like he goes to Pennsylvania, he comes back to Nashville, and then he goes back to Pennsylvania.
Right.
That's his last trip, and then obviously reverses it the next day. So obviously there's a ton of work. I'm not a pilot. I'm not downplaying how difficult that job is.
That's not difficult.
But essentially, I mean, it may be like 5 hours of work.
It's not hard. Now there's some work on the front, and there's obviously some work on the back.
That's what I mean. Like there's stuff
but it's not what they're doing is because they're flying the same route over and over again. They know exactly what's going to happen.
Yeah.
As long as the aircraft is operating normally, it's just a non-issue. They just literally flying fixed wing cross country or whatever, flying a long flight. You do your planning. Okay, our numbers that will keep us safe. In other words, if we lose an engine at this point, we're going to have to, before this point, we're going to have to, take the engines back to idle, apply brakes so we don't run off the runway.
Yeah.
Beyond that, we're in a risk area, so what we'll do is add power to that other engine, and you have some procedures. And then once you get, normal flight, you take off 200 feet, you engage the autopilot, you flaps and gear, bring those up, engage the autopilot, and then
you have a beer.
You sit back, do a line of Coke, and then
you party.
And you just sit back and watch because you've put in, thanks to good development of good systems with the test pilot community.
Yep.
You have a quality system that it tunes all the navigation radios you need along your route through this flight management system. And you're just making sure that I didn't fat finger something in there incorrectly.
Yeah.
Like, hey, we should be turning right up here, 3, 2, 1. Okay, there's our right turn.
I got you.
All right, back to whatever.
I understand. Yeah. Okay. I always pray. Laura's like, I'm not a great flyer. I'm sure I've said it multiple times. I'm not a great flyer, but anytime I have a pilot that looks like he's a grizzled war veteran, I'm like, this guy. I like this is
maybe
this. I like this guy. There was sometimes you have the pilot that's a comedian, and he like wants to joke around. You're like, I wish you would focus more on flying the plane. Like your joke was funny, but not funny enough to make me feel comfortable.
There's enough margin where their joke telling wouldn't interrupt their, because it's like what literally what they do is once they engage the autopilot, they have tons of bandwidth.
I'm sure you get asked this question a lot, which is a different direction. So flight school is obviously difficult.
Yeah.
And how many people actually make it through it?
Most make through it.
Most make it through it?
Oh, yeah.
Like a high percentage, like 80%?
Probably about 90% because they do a good job of selection. They do a good job of training.
So the suggestion is on the back end, they weed out all the people that may not be desirable before they get into flight school.
Right, through aptitude testing and that sort of thing.
So they're able to weed out some of the...
Yeah.
Because there's other branches like maybe something like a Navy SEAL training that's hard to make it through. That's a different thing, but like hard to make it through like Hell Week or whatever they call it.
Right.
But test pilots, which makes a lot of sense that you want to, on the back end, eliminate a lot of the... not weak, but like maybe people that definitely aren't going to make it with an aptitude test or something.
Yeah,
I'm sure it's difficult.
It's difficult, and the way it's a different, like you said, it's a different, a different person that you're looking for. You're looking for somebody that doesn't quit and is a team player, in like SEALs or special operations. Somebody that's not going to quit.
Yeah,
they can think on their feet.
Yeah,
and they can work well with the team. Because if you have somebody, that guy might be the best athlete, he might be the strongest, the fastest, all the above. But then if he's not a team player, I don't want that guy. It's
not going to work. Yeah,
he's the worst. Test pilot community is way different. Now you can see some folks. There is a certain amount of arrogance in that community. The test pilot community, better than Top Gun.
No, I mean like it's like the arrogance of Top Gun.
Yeah.
Yeah. Okay, I gotcha. It's better than Top Gun.
Way better. And so, but that's not what they're not trying to weed those guys out because it's that you're not working as in a team where you're relying on somebody so much all the time.
Yeah.
As opposed to what gets people most out of test pilot school is writing. And it might seem weird, but if you think about it, you can be this great test pilot, but if you can't convey in words what it means, what these engineering figures mean that you've collected the data for, and what the so what is at the end of that paragraph that says, and this is why this is a difficult aircraft to fly because you made a little statement in there. If you can't convey that, you might be the best engineer ever and do partial derivatives till the cows come home.
Yeah.
But if you can't convey that information to a so what, then you're not going to be a good test pilot. And that's really what we're looking for. Yeah,
because you have to be able to take the data and then also relay it correctly so that the things are addressed appropriately.
Right.
Yeah, that makes sense. It's interesting. It makes more sense now that a higher percentage pass or get through it if they do some weeding out in the beginning.
Right.
And then, but you also said there's still a pecking order where you're like, okay, it's okay if that guy.
There is a pecking order, and there's a pecking order once you get to my last job I had at the test center that did all the flight testing for the Army. I was kind of like the chief of staff, and so I had we all kind of had a say at that level of, okay, this guy really shouldn't fly these tests.
Yeah,
we need somebody with more experience. We need somebody with better hands.
Gotcha.
We need somebody with better engineering sense. We need a self-starter because he's going to work by himself, this project by himself, along with maybe one engineer. And so you put the right tool in that position.
You said that you had a guy that you flew with that one day that you had the experience that was not the best. Do you always work with a partner, or was it just that this scenario that you were in that particular instance?
So each of these tests, like you have a test project that comes up, and you're going to be on that project for years.
Yeah.
And so there are only so many test pilots that you have in your organization. So let's say we're doing the MH-60M testing was kind of like that. It went on for a number of years, but there was only so many people you have to do a self-qualification in the aircraft because there is no qualification course because the aircraft's not fielded yet.
Yeah, so you have to go up yourself and fly it.
Right.
Yeah.
If you're coming in kind of later, or you figure it out as a very small team. Okay, we're going to do this. We're going to fly like that, and those kinds of things. And you define that as a small test team, like we did on the fly-by-wire Black Hawk. But on the special operations aircraft, that was a much longer program because it actually got fielded. There are only so many folks that are on that team, and then you just rotate. This rotation I'm flying Jeff half the time, and the other half I'm flying with Phil.
Gotcha.
And so you're paired up every day. Like, okay, I flew the clipboard last time. You're gonna clipboard, and now I'm gonna do this.
Just go back and forth.
Yeah,
I gotcha. It's not necessarily a team. You're just flopping back and forth and getting more data.
Right.
Gotcha.
Yeah, because you're collecting data for years. One of the other aspects, I talked about the performance and the stability and control, but one of the others is you do these maneuvers. There's two different types that are kind of crazy flying. One is engine airframe compatibility, and that's where you're trying to every system has a vibration. Even this table, it's got a natural frequency. The microphone, the condenser inside here has a frequency, and that's why you can hear my voice. Same thing with the speakers. Well, an aircraft has that same attribute, and it's the total aircraft plus the individual components. Yeah. And if this engine, or there's two engines, if they are incompatible in certain ranges of what you're doing with the aircraft structurally, then you need to define that. So you take strain gauge data or vibration data on different components of the aircraft and do that. And the other one is flight load survey, which is similar set of maneuvers. But what you're trying to do is define the parts life for the whole aircraft, all the components of interest, especially the dynamic or the spinning or rotating components. You do a long series of tests where you're flying this off of this whole 3D matrix of maneuvers that you're doing, and it helps the modelers of the total aircraft define, okay, here's our cutoff point where beyond 1,000 hours, this part has to be replaced. Otherwise, it's going to come apart because we saw it in flight test data. Here's our safety margin, and then here's the good area. So if you fly it in this area, you'll be good. If you fly it into this, go greater than 60 degrees angle bank, then we're going to have to remove that part a little bit earlier than we wanted. So the lifing of individual components comes from that.
It's very interesting, Adam. I have one more question.
Yeah, go ahead.
Before you ever flew off in a helicopter, did you ever pull a pair of aviator sunglasses out of your chest, put them on, and say, let's light this candle?
I never did that. Now, I did that as a joke, just flying.
Okay. I mean, that would have been awesome.
Yeah.
Let's light this candle.
Did
you have the mustache? You didn't have the mustache back.
No, I didn't have the mustache thing. There was a famous pilot in the Air Force. He flew in Vietnam, maybe Korea too, but definitely Vietnam. He was famous for his mustache. I need to look that dude up. Maybe Abby, the intern, can post a picture. That dude had a magnificent mustache.
And he was a pilot in that area?
Yeah, so he flew F-4s in the Air Force, I think, and flew over Vietnam a ton of hours. But he was kind of like this, I don't know. He was kind of like slightly rebellious, but still safe.
Yeah.
And one of those guys that, guys follow him just because he was an interesting dude.
Yeah, that's fair.
Yeah.
That's fair. Cool.
So that's my test pilot story. I could tell more, but it gets kind of boring. And most test piloting is incredibly boring because the idea is when you move a control or a stick or whatever, some kind of control surface, or you push a button, you've done enough research and planning and engineering on the front end that you pretty much know what's going to happen with about an 80% certainty. Yeah. Every once in a while you get surprised, and then that's when you end up writing papers. You write reports anyway. You're writing all the time, daily reports, all these, just constant writing. But you're going to be presenting something in front of some form, at least to inform the community, hey, look out for this. We had this incident, and it can translate into other aircraft. And you share those lessons learned.
We maybe should have a part 2 about this, because I can ask questions all day long.
If it's not too boring to people.
It's not boring to me.
I don't like identifying as that guy.
Yeah.
Because I'm just Adam. I enjoy having a good time, and I have opinions on several subjects, sometimes 2 opinions on the same subject.
That's fair. That was very interesting, Adam. And I got lots more questions in the future, so maybe we can talk about this again sometime.
Maybe we'll have Tony Moffitt. I've been wanting to have him on the podcast.
Yeah.
He was a test pilot. He worked at NASA for a number of years.
Okay.
And
does he know about aliens?
He might have an opinion or two about aliens
I
too.
might ask him about that. Let's have him on.
Yeah.
Okay. I'll don't warn him. I want to barrage him with a bunch of alien questions and watch him sweat.
I think he was the one that kept the set where they had the NASA moon landing.
Oh, okay.
Filmed.
So he's got a little bit of information.
Yeah, I'm just kidding.
Yeah. We all know the Earth is flat. So
Clearly.
that couldn't have happened.
Yeah.
Cool. That was very interesting. Awesome.
So, well, I'm glad you enjoyed it. I hope the listener did. Let us know. Give us some feedback on what you thought. And other than that, we will see you next week on Mishmash Men.
See you guys.
See ya.